Well, hi there, this is another video from me. It's about the FM transmitter that I got from Simon as Christmas present. So I was using the circuit board, I was sitting next to my laptop computer and playing computer games, and there was a loading screen on the computer game, and I was having a look on the circuit board. I took it and looked at it, and how did they make it? I was just curious. And there are a few things I found out. First of all, this coil. For a FM coil, it has way too many turns. Second, the oscillator design. Here's one capacitor switched parallel to this resistor. This resistor goes from emitter to ground in the oscillator stage. And guess what? This capacitor has 100 picofarads. And no, you don't want your 100 picofarads capacitor on a FM transmitter from emitter to ground, because that will pretty much cause the oscillator it will stop the oscillator oscillating. So I've took out my communications receiver and scanned through the frequencies, and look what I found out. We are on 25 MHz, and if I now push play, you can clearly hear the music, so it's obviously this transmitter transmitting on 25 MHz. Why is it transmitting on 25 MHz? It's causing some weird noises now, by the way, but that's sometimes the receiver. However, why is it transmitting on 25 MHz? Well, the developers of the circuit were very clever. They thought, I'm using a 25 MHz oscillator, multiplying the frequency by 4, and I get a very stable frequency on the FM band. Yep, that idea is not bad, and it's often used in amateur radio transmitters. For example, a 2-meter transmitter uses a 16 MHz crystal, and then it multiplies the frequency up until it gets to 144 MHz. This one works pretty well, and the point of this is to get a very stable signal. And how do they filter out the FM signal? They have got one tank circuit here and one tank circuit in the output stage that filters out the FM frequency. But you pay a price for this type of design. You can do a transmitter based on the low frequency and then filter out the high frequency, but it's very, very complex. This one uses just 2 tank circuits that are tuned in the FM band. Okay, no problem. But the price you pay for this is that you not only get a signal on the FM band, you also get a signal on the 125 MHz, which is airplane band. You also get a signal on around about 150 MHz, just depending on how you tune the slug of the coil, because this transmitter is adjustable in its frequency. And these are 2 frequencies you don't want to transmit, because you can get in trouble if you transmit on these frequencies, because you can interfere with other users. So, for those who are interested in buying this transmitter, it can be bought for around about $6, including shipping, and you get the complete ready-made circuit board. It's working, just plug it in and it works. For $6, really cheap, but I would not connect an antenna to it. I would connect an antenna to it if I made an additional PI filter on the output, which is very narrow-banded, very sharp to tune, very narrow-banded. Then you could use it, but still I'm not that happy with that circuit. I mentioned in the previous video that it can't be stereo modulated. I tried to modulate it with a stereo signal. I got the MPX signal input, and the stereo LED lit up. It showed me that it's stereo, but no, it wasn't stereo. I was listening to it with my headphones, and there was not really any channel separation. So this is just cheap, no channel separation. And yeah, it's a mono transmitter for playing around, experimenting. You can go ahead and buy it, but for serious transmission, I'm sorry, I do definitely not recommend this one. So that's a cheap transmitter. Best regards from Stefan.